In this video, we're going to introduce the concept of circuits and expand our knowledge on electric fields. The first thing we need to look at is that there are two different types of circuits, the alternating current and the direct current. Now the basic difference comes about because of this thing called current. And current is the amount of charge that flows across a given point in a given unit of time. This is the number of electrons that will cross a certain point. And the electron has a charge of 1.6 times 10 to the minus 19 coulombs. Just to explain this a little bit more clearly, we consider a portion of wire through which some current is flowing. So in this diagram you can see we have our wire, and it has a bunch of little electrons flowing in it to the right. Now if we were to sit at a certain moment, or a certain point, and watch for a small moment of time, how many electrons were to cross this area, that would give us our current. And the units of current are the ampere or the amp. It's 1 amp is equal to 1 coulomb per second. And if we were to convert this into electrons, this is 6.25 times 10 to the 18th electrons per second, which is a lot of electrons. Now back to our original thing of the two different types of circuits, alternating and direct current. In DC current circuits, direct current, the current flows like this picture up here. All the electrons flow from one side to the other. However, in AC circuits, the electrons are going to flow one way and then move backwards, and then flow the same way again, move backwards and back and forth very rapidly in the circuit. And this is a type of circuit that we'll actually consider later. For the rest of this duration, we're going to just look at DC circuits. Now let's go back to the idea of voltages in DC circuits. And just to remind us, voltage is what drives a circulation of electrons in the circuit. So if we have a higher voltage in a circuit, the more powerfully the electrons are pushed around the loop. Now the most common type of voltage source that we have is the battery, which is a stable voltage that lasts pretty long time, but at the very end of its lifespan that voltage will start to decrease. Now a battery is a little bit different than a capacitor. Both of them do have the ability to store some charge. However, a battery is a chemical reaction, so it has a little bit of a different characteristic. So you can think of batteries as a voltage source. So let's look at a copper wire. Without the voltage, the current's not going to flow around this copper wire, or the electrons that are in this copper wire are not going to flow. However, if we were to add a battery in here, put the plus side here and the minus side there, what's going to happen is that this voltage, say it's a 9-volt battery, that there's 9 volts that are going to drive the electrons to flow around this. What's going to happen is the current is going to flow around this in a clockwise manner. And 1 volt, again, is 1 joule per coulomb. However, it should be noted that the electrons are actually going to flow in the opposite direction because electrons have a negative charge. It's very common for us to talk about the current, and the current meaning the flow of theoretical positive charges, but really what's happening is the electrons are flowing backwards. And with that, this concludes our introduction to DC circuits. In the next video, we're going to actually see the use of some fun little laws like Ohm's law, which makes everything able to be solved. And I'm going to eliminate that.